Okay, so I managed to get into the school briefly and get some wires, and so we're going to try to do a lab watch, try to figure stuff out as we go. Hope this works. I had to like mess with changing batteries and things too, but let's see if you can see this. Maybe you can see that, I hope. So what we have here, we have a multimeter. It's got a voltmeter, measures potential difference. It's got an ammeter that measures current, and it can even measure resistance in ohms. And so I've got batteries and light bulbs and also a resistor that's supposed to be a resistor. First thing, let me check. I'm going to take one of these batteries. I hope they're good. I'm going to turn this thing to volts. So here's volts. I don't have a lot of volts. I'd say 20 is kind of about how many. It's not really that much. And I am now going to measure the potential difference across the battery. So I hook this up to one end and I hook the ground end, so to speak, up to the other one. And it says, what does it say? 1.58, which is good because it says it's a 1.5 volt battery. So it's giving me an extra 1 or 0.08 volts, I guess. Let me try this. How about I'll take 2 batteries in a row. I'm going to put the negative terminal of one battery up to the positive one of the other. Well, actually, I should have checked this battery separately, maybe. Let's check this battery. Is it the same? Let's see. 1.58. They're both 1.58. So I wonder if you can guess, before I even have to hook it up, what will the voltage be across the 2 batteries which have been placed in series? You see, there's one after the other. I'm going to measure across the whole thing. And here we go. Oops. What do you think? It's 3.17, which is just about 1.58 plus 1.58, plus a little extra there. Oh, maybe it's a little round off error. So anyway, I've got some good fresh batteries. And let's see what we can do with the batteries. Well, I'll tell you what, I also have a resistor. You see that? Resistor. It's sold as a resistor. It's meant to resist. And how much does it resist? Well, there's a little code thing with the stripes. And I believe, yeah, I can read this code. This code of little colors on the resistor, you don't have to learn this, but the little brown, black, gold thing there means it's supposed to be 10 ohms. I wonder if that's true. Is it really a 10 ohm resistor? One way to try to find out is to use the ohm meter that tries to push electricity through there and tells how many ohms it is. I'll turn it to here. How many ohms we got? It's going to try to send some electricity through there and see how hard it is, see how much resistance it gets. And that's not, okay, it was right. Oh, there it is. There it is. It says 1.17, 11.6, keeps changing its mind. 11.6 ohms. That's not really what it's supposed to be. This thing's not really within specs exactly, but it says it's 11.6 ohms. So if I take, get ready to calculate, if I take 3.17 volts worth of batteries and put it across a different color, and put it across this resistor, it completes a circuit, you know. So I wonder what the current is. You should calculate it. 3.17 volts. Gee, I don't have a calculator with me here. I just could use that. But anyway, 3.17 volts divided by 11.2 ohms. Well, if it was divided by 10, it'd be 0.3. Divided by 11 is a little lower, like 0.2 something. You ought to calculate it, 0.2 something amperes. Well, I'm going to turn this thing to amperes. Where are they at? Probably going to be, I'll leave it on that one. Try that. Now, here's the thing. To measure a, there you are. To measure a current, I have to put the meter into the circuit. It has to become one with the circuit, part of the circuit, so the current will really go through the machine. So what I'm going to do is I have to, ow, it's getting hot. Dang, it's hot. It's dissipating power. Really quite hot. Almost burned me. So I'm now going to see how many amperes. We're thinking it's like 0.2 something. And what's it going to say? Not saying anything right now. What happened? Ah. Please say something. -1. It's not happy. Great. I'm making a video and now it's giving me trouble. Arg. Do I really have to troubleshoot on a video? Let's check my circuit. My circuit exists. Got everything plugged in. It's not enough amperes to worry about that, so I should be able to turn it to my milliamperes. Oh, there goes. Well, shoot, it did for a minute. One more try. Nah, okay. Okay, that's happy now. It says negative, don't worry about that, but it does say about 0.22. The negative is because I plugged it in backwards. But anyway, 0.22 amperes, and you should probably got 0.2 something when you divided 3.17 by 11.6. So our number, I believe, is a little on the low side. It's reading a little bit too low. I wonder if you can think, why would I get less current than I had predicted? I wonder if you can figure it out. I might just have to show you why we're getting less current than we predicted. What I'm going to do is take a wire. Oh, shoot, I unplugged the thing. Okay. Going to take voltmeter thingy, go in there. I don't think these are made for that. I'm going to actually measure the resistance of a wire and see if the wire has any resistance. Moment of truth. Yes, indeed. Even this piece of wire has a resistance of 0.8 ohms, and so did a couple of other wires there. So I suspect what happened is I got that low current reading because this resistor wasn't the only resistance. The wires were accidentally having some of their own that combined with it to make more resistance and less current. So anyway, you've seen what happens with that. Now what I'm going to do is do something a little more visually appealing. I think I'll do a light bulb. Here's a light bulb. Now, I think what I'll do is, first of all, simply make it come on. That makes people happy to see a light bulb come on. And a light bulb goes off in your head or on the table. So, here comes, hopefully, a light bulb. Why, of course, the light bulb came on. We know we have That's 1.58 volts there. And the light bulb is on. I wonder how much current there is. Let's find out how much current there is. Seems to me I'm having to use this thing. So I'll turn it to current, probably that kind. And I once again get into the circuit. Get in there. I don't care if it says positive or negative. Okay, I have to get in the circuit. That means I got to put this over here. And my light bulb is, oh, because it fell out. There it goes. There it goes. It says 2.1. 2.1 what? 2.1 amperes? Really? That much? It says it. So what would that make the resistance of this thing? I'm really surprised at 2.1 amperes. Does it mean milli? You can now calculate the resistance of this. I'm really worried about the 2.1 amperes. I think oh well. In any case, the light bulb is on, and you could calculate its resistance by dividing 1.58 volts by the 2.1 amperes, and you get less than an ohm, I think. Still not 100% sure about that. But let me do something else. Let's put two batteries in a row. If I put two batteries in a row, that's like going up a taller elevator. There we go. And I'll hook that up. That's not really what I want to hook up first. This is. Let's see what the light bulb does now. You think it'll be like twice as bright with two batteries? You think? Or will it be way brighter? Oh my gosh. Why is it so much brighter? It's not just twice. Did you see that before? We don't want anywhere near that bright before. Look at this. Look at this. See that? That's not real bright. When I put two of them on there, dang, that's bright. It's many, many times brighter. Now, why would that be? Well, I've got twice the current flowing if it's the same resistance. But, you know, if P equals IV, you figured out how many times brighter should that be. Let me do something else. How about I'll put two light bulbs in series with each other. When I put them in series, I now have, let's see, put them in series, I've got, when I put two of them in series, is that going to be brighter or less bright or what? Let's see. You know what? Now they're back to being kind of dim again. Why is that? Well, I've got 3 volts across the combination, and there's 2 fairly equal resistors there. So how many volts is across each one? Probably splits it. And now the light bulbs are back to being just about how each one would be on its own. In other words, probably, if I were to unhook this one and then just use one of my batteries, yeah, about the same deal. So it was 1 point, if it's, say, 3 volts across the combination, then I have 1.5 volts across each of these two. As one more thing I want to do, I would like to, oh, you know what I didn't do yet? I did not measure the current through a combination of the two. When it's blazing bright like this. Yeah. What I want to do is measure this current. I should be able to use the same little setting here. Probably that one. Maybe that one. And I got to get this thing into the circuit. It has to become part of the circuit so I can measure the current. And when I do, thankfully my light bulb still works, and I'm getting 0.29. It is a greater current than before. was it 0.29 or was it 2 point? I might have to go back to checking one again. Anyway, this says 0.29. I'm going to have 2 batteries and 1 light bulb. I'm going to go back to the 1 battery version. And now it says, my point was in the wrong place all along, but I did that before. Now it says 0.20. So this is less current. However, if you calculate the resistance using V equals IR, you'll say 1.58 volts, try it, divided by 0.21 amperes should give a resistance of 7-ish ohms maybe. You figure that out. See how many ohms that is. Figure that out. And when I come along and use 2 batteries, I get more current. That's not a surprise. Yep. More current. And I'm up to about 0.3. I would have thought it would have doubled the current. Figure out the resistance from this. Maybe we'll talk about that in a video. Maybe we'll do that. I won't have to do it live. You can see it right there. That deserves some discussion. We'll talk about it. Now, one more thing. I want to put 2. First, I'm going to put them back in series. Put them back in series. Hope you can see what all I'm doing. Okay, so here's my 2 light bulbs in series. They won't be very bright because the voltage is getting split across them. Not much for each one, right? And in this case, we're in series. Let me put them in parallel with each other. Parallel means they have a choice. Oh, by the way, if I take one of the light bulbs out, they both go out like a Christmas tree strands used to be, and I have to find the right bulb. Let me put them in parallel instead, where there's a choice. To do parallel, to give them a choice, what I need to do is kind of like, now there's lots of ways to hook it up. Probably the simplest thing is going to be for me to say, you can go through that one if you want, or if you like, you can go through the other one. I need to give a path. I need to give it a chance to go through there, but where does it want to get to? It wants to get back to where it can head back to the battery. I want to say you can go through here if you want, or you can go through this one if you want. Look at the ones going through the yellow, they're bypassing this one, going through the red around here. Then they go through that one. Okay, but I want to give them a chance to go through this one. So I think if I hook this up, I wonder what will happen overall. Ooh, they're both pretty bright. They're both pretty bright. They're in parallel. It's a little hard to see, but I am actually giving an option. The current flowing in here, maybe it comes this way. The current flowing in here has a choice. It can go and head through that one and light it up, or it can go through this one and head through there and light that up. And if these are your Christmas tree bulbs, and I undo one of them, I wonder what will happen to the other one in the strand when I undo this one. Get up. There, I took it. Oh my goodness, this one's still on. Ever so slightly bright. It's a slight difference in brightness for some complicated reasons I don't want to get into too much right now. But anyway, that's resistors in parallel. What else is there to say or show? Well, one thing I'll show. I'll check the voltage across them. I'll turn this thing to volts, and supposedly we will have the same potential difference across either one of them. So I'm going to check the potential difference across this. It ought to be something like, dang it, it ought to be something like 3 volts across this one. Let's check. 1.9 something. That's less than I would have thought. You check it across this one. Not good contact. About 2. Funny stuff's going on because of the resistance of the wires. They are offering some resistance and sort of messing things up. Anyway, you've now seen batteries get hooked up in series and resistors in parallel and series, and maybe we'll talk about this a little bit in the video, in a class in a couple of days. So anyway, this may also show up a little bit in your homework questions. Have a good one.